mathematicians. Today we are going to start a chapter talking about triangles. Today we are going to focus on just classifying them. The first way we can classify triangles is by their angles. Acute, remember, is less than 90. Less than 90. So if you have three angles that are less than 90, this is an acute triangle. Okay. So three angles less than 90, it's an acute triangle. If there is one obtuse angle, what does it mean to be obtuse? Greater than 90, and all you need is one of them. That one would be right here. This is what we would call an obtuse triangle. If you have one right angle, and we notice that it is here, we would call this a right triangle. And if we have a triangle where all three angles are the same, we call this equal angular. Equiangular. Equiangular. Just means all angles are the same. So using the diagram, classify each triangle by its angles. So I'm going to look at triangle CDE. So this triangle here. Okay. What triangle would this be called? Well, it has a right angle right here, so it would be a right triangle. Let's take a look at BCE. BCE. Okay. These two are really small, but what do you notice about this one here? Right, it's over 90. If you think of it, a 90 would come straight out here. So this is over 90, so this would make it obtuse. Lastly, ABE. ABE is equiangular. All these little marks mean these are the same. So equiangular. Next, you can classify triangles by their sides. If you have three sides that are the same, and we know they're the same because of these little tick marks here, this is a equilateral. Three congruent sides, equilateral. If there are two sides that are equal, and I know that because there are only two of them with this tick mark, this one would not be the same. This is an isosceles. Isosceles triangle. And lastly, no sides are the same. There are no tick marks indicating that they are the same. This is what we call scalene. So three ways to tell by the sides. So for these, we want to tell the type of triangle by its angles and its sides. So let's do angles first. What do you notice? There's a right angle, so this is right. What do you notice about the sides? Two of them are the same, so that is isosceles. Okay. What about this one? What about the angles? I have one that's over 90, so that makes it obtuse. And what about the sides? No matches, so this would be scalene. Try this last one on your own. Name it by its angles and its sides. Let's see how you did. Angles. What do you notice about the angles? They are all the same, so that is equiangular. And the sides are all the same, so that makes it equilateral. So classify it by its angles and its sides. Nice job. Next, we're going to be given some coordinates, and we need to figure out the sides to tell what type of triangle it is. So if we're going to think of this triangle as JKL, how many sides are there? 1, 2, 3. So I need to know the measurement of each side. So first I need to do JK. And remember that distance formula is going to come in back from chapter 1. Subtract the x's, subtract the y's, square them, add them, square root. Subtract the x's, subtract the y's, square them, add them, square root. So I'm going to need to do this for all three sides. So I'm first going to look at J and K. So I'm going to subtract the x's, and it doesn't matter which one you start with. -7, or minus -9. And that is 2. Now I'm going to subtract the y's. -7 minus 1. And that is -8. Now what comes next? Square them. 2 squared is 4. -8 times -8, 64. Then what? Add them and square root. And you can leave it just like that, or you can find the exact measure. So that is this side here. Go ahead and find KL and JL. Okay, so I'm going to use these two, find KL, then use these two and find JL. Let's see how you did. KL, using these points, subtract the x's. -9 minus -1. It's -8. Subtract the y's. 1 minus -1. That's 2. Now what? Square them. So -8 times -8, 64. 2 times 2, 4. Add them. Square root. That gives us square root of 68. Last one, JL. So I'm going to take these two here. Subtract the x's. -7 minus -1. That's -6. Subtract the y's. -7 minus -1. That's -6. Then what? Square them. -6 times -6, 36. -6 times -6, 36. What comes next? Add them. Square root. 36 plus 36, 72. Classify it by its sides. What do you notice about the three sides? 2 of them are the same, so this is isosceles. So use the distance formula, 3 sides of a triangle, so I need to find 3 distances. Tell what they are based off of those sides. Nice job. Last thing we're going to do is put some algebra in the mix. If ABC is an equilateral triangle, Solve for both x and y. What do you know about an equilateral triangle? All sides are the same. So if this one is 49 meters, what must this one be? 49 meters. And here, 49 meters. So to find x, these two must be the same. 3x plus 1 equals 49. And what about here? They must be the same. 18y minus 41 equals 49. Go ahead and solve for x and y. Let's see how you did. What do you do first here? Minus 1 on both sides. Then what? Divide by 3. X equals 16. What about here? Add 41 to both sides. 18y equals 90. And to solve for y, divide, and we get 5. So all sides must equal 49, so set both of these equal to 49. Solve. Last one. Triangle WXY is an isosceles triangle. What does it mean to be isosceles? Two sides are the same. And they're telling us which two. WX and XY. Find x and the measure of each side. So what do you know about these two sides? They're equal, so what should you do? Set them equal. 6x minus 77 equals 3x plus 4. Go ahead and solve for x. And how will you find the measure of each side? Plug it in and find each one. So go ahead and solve for x. Let's see how you do. Subtract 3x. 3x minus 77 equals 4. What will you do next to solve? Add 77 on both sides. And lastly, divide by 3. X equals 27. To find the measures of each side now, plug 27 in to find each measure. Nice job today, mathematicians.